Here are some example problems using the formula F equals ma. A girl on a scooter is accelerating 2 meters per second squared. If the girl has a mass of 50 kilograms, how much force is acting on that girl? Well, let's see what the problem gives us. It gives us an acceleration of 2.2 meters per second squared. So that's my acceleration. If the girl has a mass of 50 kilograms, so there's my mass, 50 kilograms, how much force is acting on that girl? So I'm going to write down my formula. F equals m, mass, times acceleration. And now I'm going to plug in what I know from my word problem. I do not know the force, so I'm going to keep that as an F. I don't know that. But I do know the mass. The mass is 50. And the acceleration, which is 2. So 50 times 2 is 100. 100 what? Well, the unit for force is a little bit more tricky. All right? If force equals mass times acceleration, and the unit for mass is the kilogram, and the unit for acceleration is meters per second squared, then the unit for force is, I don't have any room over there, so I'll write it down here. The unit for force is kilogram per meter per second squared. Instead of a little line right there, we're just going to put a dot, because we're multiplying kilograms, the mass, times the meters per second squared, the acceleration. Another way to write this is a Newton. A Newton is equivalent to 1 kilogram times 1 meter per second squared of acceleration. So I look back up at my problem. I see that my mass was measured in kilograms. I see that my acceleration was measured in meters per second squared. I put those together and I end up with the unit for force, which is the Newton. So the answer to our question, 100 newtons. Now this word problem is going to use the same formula. F equals ma. Sam pulls a wheeled backpack with a force of 3 newtons. If the backpack has a mass of 6 kilograms, what is its acceleration? So I know that my formula is going to be F equals ma, so I write that down. Then I go to my problem to see what I have. The backpack has a force of 3 newtons, so that's the force. Oh, it doesn't look very good. Let's try to write that again. That's the force. If the backpack has a mass of 6 kilograms, what is its acceleration? So, I know that the backpack has a force of 3. I know that the backpack has a mass of 6, but I do not know the acceleration, so I'm just going to leave that A. So 3 equals 6A. Now to solve this problem, we have to isolate the letter A, or get it all by itself. So we have A equals, acceleration equals. So right now we're multiplying by 6. The opposite mathematical operation is to divide. So to get the 6 over here, which is where we want it to go, we're going to have to divide by 6. So divide this side by 6, which will allow me to cancel that out, leaving A all by itself. But remember, what you do to one side, you have to do to the other side. So, oops, we're not going to multiply, I'm sorry. So if we divided the right-hand side by 6, we also have to divide the left-hand side by 6. So we end up with, I'll rewrite this, we end up with A equals 3 divided by 6. 3 divided by 6 is 1/2, or 0.5. 0.5 what? Well, let's go back up to our problem. If our mass was measured in kilograms, and our force was measured in newtons, which is the same thing as a kilogram per meter per second squared, remember? I see kilograms twice, so I can cancel that out, and the only thing I'm left with is my unit for acceleration, which is meters per second squared. The final problem, also using our same formula, a model rocket is accelerating at a rate of 3 meters per second with a force of 1 Newton. What is the mass of the rocket? Well, I'm going to write down my formula because that's always the first thing that I do. And then I'm going to go to my problem and see what I have. It says that the model rocket is accelerating at a rate of 3 meters per second. Well, that's the same thing as meters per second squared. There's 2 of them. So that's acceleration. With a force of 1 Newton, so that is my force. It's my force. What is the mass of the rocket? So let's plug in what we know. We know that we have a force of 1 Newton, which equals mass, I don't know the mass, times an acceleration of 3. So I do this very similar to the last problem. I need to isolate the m, or get the m all by itself. So I need to move the 3 to this left-hand side of the equal sign. Do you remember how we move numbers or letters over? That's right. We do the opposite mathematical operation. So we're going to divide this side by 3, which will let me cancel that out, and m is by itself. I divide this side by 3 also. Remember, what you do to one side of the equation, you do to the other side of the equation. So let's rewrite that. I get m equals 1 divided by 3, or a third, which is 0.33 repeating. And now I need the unit for mass. That's what I was looking for, the unit for mass. Remember, though, that the Newton is the same thing as a kilogram per meter per second squared, and acceleration is meters per second squared. So if those cancel out, then all I am left with is the kilogram, which is the unit for mass, and that's what I was looking for. So our answer is 0.3 repeating kilograms.